Dear students, welcome to the class. I am Dr. Tirupathi Reddy, Department of Mathematics, B.V. Raju University of Technology, Narsapur. In this linear algebra and calculus course, we are going to see the statement of mean value theorems. Let us see the first one, Rolle's theorem. First statement of the Rolle's theorem. Let the function f of x be a real valued function such that it must satisfy three conditions. First one, f of x should be continuous in closed interval a comma b, and the second condition to be satisfied is f of x is differentiable in open interval a comma b, and third condition to be satisfied in Rolle's theorem is f of a is equal to f of b. If all these three conditions are satisfied, then Rolle's theorem says that then there exists at least one point C within the open interval a comma b such that f dash of c is equal to 0. This is what the statement of Rolle's theorem. Now let us try to understand geometrical meaning of Rolle's theorem. Geometrically, the conditions of Rolle's theorem says that the conditions of Rolle's theorem says that first one, the curve y is equal to f of x is a continuous curve. And the second condition means that the curve y is equal to f of x has slope of tangent at each point in the open interval a comma b. The curve y is equal to f of x has slope of tangent at each and every point on the curve, okay, corresponding to the points a comma b. And the third one is, third condition says that f of a is equal to f of p. It means function value at the left hand point is equal to the function value at the right hand point. Geometrically, it means function maintains the same height with reference to the x-axis at the end points of the interval. So this is what the geometrical meaning of Rolle's theorem. So the first one says that the curve y is equal to f of x is continuous curve, and the second one says that the curve y is equal to f of x has a slope of tangent at each and every point on the curve, okay, has slope of tangent at each point on the curve. And the third one, endpoints are maintained at the same height with reference to the x-axis. Okay, if these three conditions are satisfied, then Rolle's theorem says that there is a point C in the open interval a comma b such that f dash of c is equal to 0. So geometrically it means slope of tangent at a point x equal to c is parallel to the x-axis. This we will better understood by taking the rough sketch. So let us take the rough sketch first. x-axis, y-axis. Let us assume that curve is like this, and this point is given by the left hand point capital A, and this is capital B, B comma f of B, and this is A comma f of A, and this is the point corresponding to A, and this is the point corresponding to B. If this curve is continue and this curve is given by y is equal to f of x, if this curve satisfies all the conditions of Rolle's theorem, then Rolle's theorem says that between A and B there is at least one point here where slope of tangent is parallel to the x-axis. Okay. Similarly, the curve may be in another fashion. We will see. Here it is. This is given by f dash of c, and this is the value corresponding to the c. Okay. Now we will see the rough sketch in another fashion. Curve may be like this also, and this is the point corresponding to A, and this is the point corresponding to B, and this is capital B, B comma f of B, and this is capital A, this is A comma f of A, and this is given by curve y is equal to f of x, and we have x-axis as well as y-axis, and all the conditions of Rolle's theorem are satisfied. If you observe here, endpoints are maintained at the same height here. Endpoints are maintained at the same height with reference to the x-axis, and the curve is continuous as well as differentiable. Then there is a point between A and B where the slope of tangent is parallel to the x-axis. So here slope of tangent, this is given by f dash of c, and this slope of tangent is parallel to the x-axis. And we mentioned in the statement of the Rolle's theorem that at least, we mentioned one word, at least. That means there may be more than one such c in the open interval a comma b. To illustrate that, let me take the another rough sketch here. So this is the point corresponding to A, and endpoints has to be maintained at the same height with reference to the x-axis. This is point B, B comma f of B, and this is capital A. It represents A comma f of A, and we have one tangent parallel to x-axis, another 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 tangent parallel to x-axis. Then you can label this as some c1, this as some c2, this as some c3, this is c4, this is c4, and this is c5. Likewise, there may be more than one such slope of tangent which is parallel to the x-axis. This is what the geometrical interpretation of Rolle's theorem, right? So algebraically, Rolle's theorem says that f dash of c is equal to 0. That means for any function f of x which is defined in the interval closed a comma b, satisfying all the three conditions of Lagrange's Rolle's theorem, all the conditions of Rolle's theorem, then this Rolle's theorem says that there is at least one point c in the interval a comma b for which f dash of x is 0. That means f dash of x has a root in the interval a comma b. So it means f dash of x has root in the interval a comma b. Now let us see the statement of Lagrange's mean value theorem. Let f of x be any real valued function defined in the closed interval a comma b such that it must satisfy two conditions. First one is f of x is continuous in the closed interval a comma b, and the second one, f of x is differentiable in open interval a comma b. Unlike in Rolle's theorem, here we are not going to consider the third condition. If these two conditions like continuity and differentiability are satisfied in the closed and open intervals respectively, then Lagrange's mean value theorem says that there exists a point C in the open interval a comma b such that f dash of C is equal to f of b minus f of a by b minus a. This is what the statement of Lagrange's mean value theorem. So geometrically, the first two conditions of Lagrange's mean value theorem are same as that of the first two conditions of the Rolle's theorem. So first one says that the curve y is equal to f of x is continuous curve. And the second one says that the curve y is equal to f of x has slope of tangent at each point on the curve. At each point on the curve. In fact, that slope of tangent is always unique. The function y is equal to f of x has a unique slope of tangent. You can write unique slope of tangent at each and every point on the curve. In fact, the second condition has one important observation. If you see the rough sketch here, this curve has infinitely many points. Therefore, you can have infinitely many slope of tangents. But at each and every point, you will have only one unique tangent, one tangent, slope of tangent. So, as there are infinitely many points, you will have infinitely many slope of tangents on the curve. But at each and every point, you will have unique tangent. That is what the important observation you have to remember. So, when these two conditions are satisfied geometrically, then Lagrange's mean value theorem says that there exists a point C in the open interval a comma b such that f dash of C is given by f of b minus f of a by b minus a. So to make this understand, let me take some rough sketch here. This is the rough sketch. Let me draw the curve like this. This is the point corresponding to A and this is the point corresponding to B. This is capital B, B comma f of B, and this is capital A comma f of A. So unlike in the previous case, here third condition we are not going to consider. So this curve is continuous as well as differentiable and end points are not maintained at the same height. We are relaxing the third condition. In that case, there is at least one point on the curve where slope of tangent is parallel to the line joining the end points, and this is the line joining the end points A and B, and it has name called chord, CHORD. Okay. So slope of tangent is parallel to the chord joining the end points A comma B, right? This is what the geometrical interpretation of Lagrange's mean value theorem. Let us consider the another rough sketch. Here endpoints are not maintained at the same height, and this is the point corresponding to B, and this is the point corresponding to A, and x-axis, y-axis, and slope of tangent is parallel to the chord joining the endpoints, and this is corresponding to C1, and this is C2, and this is C3, and this is C4, and this is the curve y is equal to f of x, and this is the point B comma f of B, and this is the point capital A comma f of A, and this is the chord joining the endpoints A comma B, right? So here slope of tangent is parallel to the chord joining the endpoints, and this is the rough sketch will illustrate about there is at least one point C in the open interval A comma B such that f dash of C is equal to f of B minus f of A by B minus A. And we should not forget while writing, there exist at least, there may be more than one such a C in the open interval A comma B. Now we will see the statement of Cauchy's mean value theorem. Before that, let us take the algebraic meaning of this Lagrange's mean value theorem. For example, if you consider the rough sketch, and this point is given by a comma f of a, and this point is given by b comma f of b. So if you consider a and b as 2 points x1, y1, x2, y2, and the slope is given by m is equal to f of b minus f of a by b minus a. But Lagrange's mean value theorem says that f dash of c is equal to f of b minus f of a by b minus a. Algebraically it means the exact rate is equal to the average rate. There is at least one point in the interval a comma b, the average rate from the point a to b is equal to the exact rate in at least one of the points between a and b. That's what the algebraic meaning of Lagrange's mean value theorem, right? So mean rate is equal to the exact rate at x equal to c. This is what the algebraic meaning of Lagrange's mean value theorem. Now let us see the statement of Cauchy's mean value theorem. Cauchy's mean value theorem is the general case of the Lagrange's mean value theorem. Instead of considering the one function f of x, we are going to consider two functions. Let f of x and g of x be two real valued functions, such that it must satisfy two conditions. First one, f of x and g of x should be continuous in closed interval a comma b. F of x and g of x are continuous in closed interval a comma b. Second condition, f of x and g of x are differentiable in open interval a comma b. And the third one, we must ensure that the second function g of x derivative should not be vanished in the domain a comma b. If all these three conditions are satisfied, then by Cauchy's mean value theorem, it says that there exists a point c in the open interval a comma b such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a, and this is what the statement of the Cauchy's mean value theorem. So therefore, these are the statements of the mean value theorem and the geometrical interpretation. Next class we will see problems associated to mean value theorems and their verification. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.